Very good morning, students. In today's class, we are going to find the idft using the DFT expression. So you have to find the idft of the 4-point sequence x of k, which is given as 6, 0, minus 2 and 0 using DFT. So the new expression which is used to find the idft using DFT is x of n is equal to 1 by n DFT of x conjugate of k, the whole conjugate. So this is a new expression for you to find the idft using the DFT. Please make a note of this expression, right? So how to find x of n? So the procedure is you have to find first what is x conjugate of k. So from the given x of k, calculate x conjugate of k, then take DFT of x conjugate of k. Again, after taking the DFT, you have to take conjugate of the DFT values, and later you have to multiply with 1 by n. So this is the procedure to find the idft of the given x of k as per the expression given above. So let us solve the problem. So what is given? X of k is given as 6, 0, minus 2 and 0. So for this we will take the conjugate. The first step is to take the conjugate of x of k. So x conjugate of k is equal to, you have to take conjugate of 6, 0, minus 2 and 0. So if you take conjugate of this, let us again 6, 0, minus 2, 0. Why? Because there is no complex numbers. So conjugate of this real number will remain the same. So in the next step you have to find the DFT of this x conjugate of k. So you know how to find the DFT. Using the matrix method, I have calculated here the DFT of x conjugate of k. So I am getting the values as 4840. So as a next step, you have to take conjugate of this DFT values. So taking conjugate of 4848, again it remains the same. Why? Because it is again all real numbers. So what is the final step is, you have to multiply with 1 by 4. If I am going to multiply with 1 by 4, you will be dividing each and every value by 4. So finally you will be getting x of n as 1, 2, 1, 2. So this is how to find the idft for the given x of k using DFT expression. So during the examination, if they specify using DFT, then you can make use of this expression and you can solve for finding x of n. So let us move on to the next problem. Find the n-point DFT of the sequence x of n is equal to 1 where n is even and it is 0 for n is equal to odd. And n ranges from 0 to n minus 1 and capital N is an odd number. So let us solve this problem. So what is given as x of n is given, you have to find n-point DFT. Whereas capital N value it is not given. Generally we are going to find what is the DFT of the given x of n. So for that, take the expression for DFT. As we know, x of k is equal to summation n is equal to 0 to n minus 1 x of n wn power of kn, where k ranges from 0 to n minus 1. So first let us write the expression for the DFT. So later let us substitute for x of n. So what is x of n given? It is 1 provided if small n is an even number. So we will be substituting only the even numbers of small n, that is 0, 2, 4, 6, 8 and so on, right? And we don't know what is the maximum value of n. Just generally we will write it as x of 0 into wn power of, whereas n is equal to 0, so it is wn power of 0 plus x of 2 wn power of 2k plus x of 4 wn power of 4k, like that it will go on till n minus 1. So next let us substitute the values of x of 0, x of 2, x of 4. So x of 0 value is 1, x of 2 is also 1, x of 4 1, x of 6 will be 1. So let us substitute those values here. So in the next step, I am just adding it. So it is 1 plus wn power of 2k plus wn power of 4k plus wn power of 6k, and it will go on up to n minus 1. So later this expression I am going to summarize. I am going to write it as infinite sum formula as summation is starting from m is equal to 0 to n minus 1 by 2 the x of n into the common value is wn power of 2k power of m, where m will be 0 to n minus 1 by 2. This is nothing but it is the average sum formula I have written, where m ranges from 0 to n minus 1 by 2. So in the next step, this x of n I can put it as 1. Why? Because it is given as x of n is equal to 1 and we are summarizing only for the n even. So it becomes 1 here. So x of n is put as 1. So 1 into wn power of 2k, it is wn power of 2k only. So in the next step, I am just substituting the formula for the infinite sum, which is summation 0 to n minus 1 by 2. If it is of the form a power of n, the formula says it is 1 minus a power of n plus 1 divided by 1 minus a. So using that formula, we have substituted here 1 minus a, whereas a is wn power of 2k whole power of n plus 1 by 2 divided by 1 minus a. Once again I am repeating the formula. The formula is summation n is equal to 0 to n minus 1 by 2. If it is of the form a power of n, it is 1 minus a power of n divided by 1 minus a. So using that formula we have substituted here. Then I just simplified for wn power of 2k whole power of n plus 1 by 2. Then after simplification will be getting us 1 minus wn power of k divided by 1 minus wn power of 2k. So this denominator 1 minus wn power of 2k can segregate as a plus b into a minus b. So what is a here is 1 and b is wn power of k. So it is of the form a square minus b square. You can segregate as a plus b into a minus b. So one term will get cancelled. So the remaining will be 1 divided by 1 plus wn power of k. So this is nothing but the DFT for the given x of n. So finally you can write x of k is equal to 1 divided by 1 plus wn power of k. So let us go with the next problem. You have to compute the endpoint DFT of x of n, which is a power of n for n ranges from 0 to n minus 1. Find the DFT of the sequence x of n, which is 0.5 power of n into u of n, where small n ranges from 0 to 3. So you have to find the endpoint DFT of a of n as well as 0.5 power of n into u of n, where the range of n is given as 0 to 3. So let us find what is endpoint DFT of a power of n first. Later instead of a we will substitute as 0.5 and we will calculate. Okay. So first write the expression for finding the DFT, which is x of k is equal to summation n is equal to 0 to n minus 1 x of n wn power of kn. Okay, in this x of n we have a power of n, which is given in the problem statement. So instead of x of n I have substituted as a power of n here, and then a power of n into wn power of kn we just multiplied, and the common term is n here. So you are getting us summation 0 to n minus 1 a into wn power of k whole power of n. So again we have the formula, infinite sum formula, which is summation 0 to n minus 1 a power of n means it is 1 minus a power of capital N divided by 1 minus a. So again I am using the same formula here. So it is 1 minus a power of capital N, right, whole divided by 1 minus a. So it is 1 minus a power of capital N wn power of kn divided by 1 minus a wn power of k. So later we will simplify and we will calculate what is the value of wn power of kn, which is 1 here, and finally I am getting the DFT x of k as 1 minus a power of n divided by 1 minus a wn power of k. So later we are going to calculate what is the DFT of x of n, which is given as 0.5 power of n u of n. So instead of a you put it as 0.5 and the given value of capital N is 4. Why? Because small n ranges from 0 to 3. From that you can calculate what is capital N. So just substitute a is equal to 0.5 and capital N is equal to 4 in the above expression. We will be getting what is x of k. So x of k is equal to 1 minus 0.5 power of 4, where n is equal to 4, into 1 divided by 1 minus, again a is 0.5 w4 power of k. So later let us simplify what is 1 minus 0.5 power of 4. We will getting us 0.9375 divided by 1 minus 0.5 w4 power of k. So this is how to calculate the DFT of the given x of n, provided the capital N is not given for a of n. Later for 0.5 power of n, capital N is given. So we just substituted and we have calculated what is the DFT of the sequence 0.5 power of n u of n. So this is a very simple problem. Okay, let us continue in the next class. Thank you. Thanks for watching.